All right, so in this video, we're going to talk about what you learned in lessons 62 and 63. Just a quick recap. So lesson 62 is on estimating arithmetic answers. So basically, this is a strategy where we want to get as close to an accurate answer, but without having to work it out on paper. We don't want to have to stack the numbers and add or multiply, whatever they're asking us to do. And the way we're going to do that, we're going to use rounded numbers. Typically, or preferably, we'd say that we want them to end in 0 because that makes it easy. So let's take a look at an example where we might use estimating to help us. So suppose I wanted you to find the perimeter of this triangle. Perimeter means the distance around. So what we're going to do, we're going to add up all the sides. And I know you might look at it and think it's really not that bad. I'll just add them all up. But nonetheless, you would still take more time than if you estimated and converted each of these to a number that's close by that ends in 0. So we would actually say 38, that's really close to 40. 42 is also close to 40. 58 is close to 60. And then we're going to add those three numbers much quicker. 4 plus 4 plus 6. Let's see, that's going to be 14. And then we're going to put the 0 on the end. And so our estimate for the perimeter is about 140. And again, our strategy is to use a rounded number. Find something that the actual number is close to, ending in 0. So a lot of times that can be a multiple of 10 or a multiple of 100, just to make it a little bit easier. This also works with money. For example, if you made the following values, $5.87 one day, and you made $13.12 the next day, and then one day you made $99.01. And we take these three values and think, well, what are they really close to? What would make sense here? And so 10 might not make sense. We could make an argument to say we could round to the nearest 10, but we're actually going to do it this way because money is easy enough. We're going to make that $6. $13.12, we're going to make that $13. And then 99, we're going to make that 100. Now you could keep that 99 if you wanted to. It wouldn't make it that much harder, but making 100 makes it a whole lot easier, I think. So 6 and 13 and 100. It's pretty simple to go ahead and add that up and get $119. Again, there are other ways to do it, but this is probably the most common way you will see. We want to pick something that ends in 0. 6. Remember, there's zeros after these. We just don't write them unless we need to. And that makes it easier to estimate and get an answer that's really pretty close. One other way you could do that, depending on how, if you're given instructions, is to round these to the nearest 10. So this is not super close to 10, but we can say, well, that's about $10. And likewise, that's about $10. It's closer to 10 than it is to 20. And then this is about $100. And you'll see 10, 10, and 100. That estimate comes out to $120. The estimates are very close because we rounded up quite a bit for this one. We rounded down almost the same amount for this one, so it balances out. And that's why estimating can be really helpful. So lesson 63, change it up a little bit. What if we take a look at subtracting fractions from whole numbers? So our whole number is 4. We want to take away 3/4 out of that. So let's think about something, right? We've subtracted and added fractions that had the same denominator, but this is a whole number. This is a fraction. How am I supposed to think about this? So 4 is a whole number. Let's remind ourselves that we can draw pictures to help us see what's going on here. And then we're going to take away 3/4. So I'm going to go ahead and split that up. And I'm going to shade 1, 2, 3/4 there. Well, how do we reconcile this? How do we make sense of this? Well, each of these, we could say that if we represented a quantity, a number that we have, we could shade the whole thing, right? Well, let's remember that each of these could be divided into fourths, and all of them would be shaded to imply or to show that we have a total of 4 wholes, right? 4 completes, 4 complete numbers, so to speak, right? But if we have 4 and want to take away 3/4, then essentially all I've got to do is take 1, 2, 3 of those fourths away. Let's look at what I've got left. I still have 3 wholes left and then 1/4 remaining. But how can we get that same answer without drawing a picture every time? What can we do? Well, let's come over here and let's think about how could we write 4 as a mixed number? For example, if you look at the original drawing where we had 4 holes and everything was shaded, that was just 4. But if we write it as a mixed number for the purpose of giving it a fraction to interact with 3/4, then we could say 3 and whatever this one was before we take those things away, right? Yes, it's 1 whole, but if we want to write it as a fraction, we could write 4/4 because 3 and 4/4 is really the same thing as 4, right? Now, what does that allow us to do? Well, when we started adding and subtracting mixed numbers, we stacked them. So let's do that. So, see what that's going to be. 3 and 4/4 minus 3/4. Now, there's no whole number to do. You'll notice 4/4 minus 3/4. Let's take care of that. 4 minus 3 is 1. I have 1/4, and then 3 minus, what's really right here? Nothing. And nothing, we say, is 0 in math. So I have 3 minus 0, 3, and 1/4. So that's really all there is to subtracting fractions from whole numbers. Let me give you one of these. I want you to write down the problem, pause the video, try it, and then we'll see what you get. So let's say I want you to do 2 minus 1/3. So like I said, pause the video and give it a try. Okay, so did you try it with the pictures or did you try it with the borrowing method where we rewrite the whole number as a mixed number? Either way, we should have gotten 1 and 2/3. Let's see how. So 2, we're going to rewrite as 1 and 3/3. Again, where does the 3/3 come from? That represents 1 whole. So 1 whole plus another whole is what gives us the 2. And then we're going to subtract the 1/3 that they want us to take away. I'm going to do the fraction part, 3/3 minus 1/3 and get 2/3. 1, take away nothing, 1 and 2/3.